C2 Geometric Sequences, past paper question, January 2006. So, we're told that the first term in a geometric series is 120. Remember that we denote the first term by A, so I'm just going to make a note here at the bottom saying that A equals 120. And then I'm told that the sum to infinity of the series is 480. So, S infinity equals 480. And from earlier on in the booklet, we know that this is equal to A divided by 1 minus R. So now in part A, we're asked to show that the common ratio, R, is 3 over 4. So for part A, we're trying to find R, which is 3 over 4. So we know that A is 120 and that 480 is equal to A divided by 1 minus R. So substituting in that A equals 120, that gives me 480 is equal to 120 divided by 1 minus R. So multiplying this through gives me 480 lots of 1 minus R equals 120. Dividing through by the 480 now gives me 1 minus R equals 1 over 4. And then that means that if I bring my 1 over 4 over to this side and my R over to this side, I'll have 1 minus 1 over 4 is equal to R. So R equals 3 over 4 as required. So that's part A done. Moving on to part B, we need to find 2 decimal places the difference between the 5th and the 6th term. So for part B, we're trying to find U5 and U6. So now I know that A equals 120, but I also know that R equals 3 over 4. Un is found by doing A times R to the power of n minus 1, which in this case is 120 times 3 over 4 to the power of 4, which gives me U5 equal to 37.96875. And U6, 8 times R to the power of n minus 1, will equal 120 times 3 quarters to the power of 5, which gives me 28.4765625. So now I'm finding the difference between them. So I'm going to do U5 minus U6, which gives me 9.49 to 2 decimal places. So that is part B completed. Moving on to part C, I'm asked to calculate the sum of the first 7 terms. So now I'm going to be using S of n, which is equal to A times 1 minus R to the power of n, all divided by 1 minus R, where n is 7, A is 120, and R is 3 over 4. So substituting in these values gives me the sum of the first 7 terms is equal to 120 times 1 minus 3 over 4 to the power of 7, all divided by 1 minus 3 over 4. So that means that the sum of the first 7 terms, typing this into your calculator, will be given as 415.92773. And that's correct to 5 decimal places. We're not told what accuracy to give it to, but considering you're told to give in part B, your answer to 2 decimal places, I would make sure it would be at least 2 decimal places, the accuracy that you keep in part C. So that's that past paper question completed.